Hello everyone, and welcome to the first video of the first lecture of the course on metric spaces. In this course, we will learn what it means to measure a distance. So let's start off with an example. We will consider the plane that we denote with the letter R2, and these are just couple of numbers xp, yp, where xp is the x coordinate and yp is the y coordinate. So if we were to draw the vertical axis of the y-axis and the horizontal axis of the x-axis, then the point P would be a point here with coordinates xp, yp, which just means that the coordinate on the x-axis is xp and the coordinate on the y-axis is yp. So we will consider the plane and we want to explain what it means to measure the distance between 2 points in the plane. So let me draw once again the y-axis and the x-axis, and let us consider 2 points. So let us take the point 0, 0. This will be our point P, and the point 3, 3. This will be our point Q. To measure the distance between 2 points means that we have to assign to every 2 points a number which is their distance. So, as for notation, we will denote the distance between P and Q will be denoted by dpq. This is a notation that says that the number dpq is the distance between P and Q. In this case, we want to define this distance as the length of the segment connecting 0, 0 to 3, 3. So we want the length of the segment connecting P and Q. In this case, this length is given by the square root of 3 squared plus 3 squared, which is equal to the square root of 18. This will be our general idea. The distance between 2 points P and Q in the plane will always be the length of the segment connecting them. So let's say that we take once again the axis y and x, and in this case we take 2 points which are general, by which we mean that we are not saying their coordinates are equal to some numbers. We are just saying we take 2 points, xp equal xp yp and q equal xq yq. And we want to say what's the distance between P and Q. Now we said we want to say that this number is equal to the length of the segment connecting P and Q. And what's the length of this segment? Well, it is the square root of xq minus xp squared plus yq minus yp squared, right? So this is the distance between 2 points in the plane. What have we done? We've given a way, a law if you want, a rule, to assign to every 2 points, P and Q in the plane, a number which is the distance between these 2 points. Geometrically, this distance is given by the length of the segment connecting the 2 points. What we want to do now is to take this nice example of a distance of this law assigning to every 2 points P and Q a number and understand what are the properties that characterize this distance, so to be able to give a more general definition of a distance which need not be only for the plane, but it could work also in other examples, for example on the real line or on the space in 3 dimensions, which is where we live every day. So the question now is the following: what are the properties that characterize dpq? The first one we see is that dpq is a positive number for any p and q. And this must be the case every time. A distance is a measurement of the space between 2 points. It could be the space between 2 parks in London, or it could be the space between 2 glasses on a table. But it's always the measurement of a space, which means it must be a positive number. The second property we can see from the mathematical formula for dpq is that dpq is symmetric. What does this mean? Well, it means that dpq is equal to dqp. Mathematically, we see that this is the case because we have squares here. So xq minus xp squared is equal to xp minus xq squared, and similarly for the y coordinates. But if we think about it, this is another property that a distance must have. If you measure the space between 2 given points, necessarily it must be the same number whether you measure starting from P to Q or you measure starting from Q to P. So every distance, every assignment of a number to 2 points, which we want to call a distance, must be symmetric, independent of where we start measuring. The third property is that a distance must be able to distinguish between 2 points. Mathematically, what we mean by this is that the distance between P and Q is equal to 0 if and only if P is equal to Q. Mathematically, this is once again clear from the formula we have here, because we're taking a square root, and we know that the square root is 0 if and only if the argument is 0. But the argument is given by a sum of 2 positive numbers, and therefore it's 0 if and only if the 2 numbers are 0. But if the 2 numbers are 0, then the coordinates of the points P and Q are equal. Once again, however, if we think about what's a distance, then necessarily two points which are different must have a positive distance, because if two points have distance equal to 0, it means that to reach one from the other you don't have to move. And said another way, it means that they are the same point. The last property is probably the most geometric one, and it's called the triangle inequality. To understand where this inequality comes from, before writing it down, let's try to understand it with an example. So I'll draw once more the axes x and y, and I will take a point P here and a point Q here. And then I will ask myself, what's the shortest way to get from P to Q? Well, we know that the shortest way to get from P to Q by experience is going straight from P to Q. So let's say that I have a third point here, let's call it R. And let's say that if I want to go to P to Q, I decide to go through R. Then I am drawing a triangle whose vertices are exactly the points P, Q, and R. By what I said before, we know that the distance between P and Q, which is measured by the length of the segment connecting P and Q, which is one of the sides of this triangle, is the shortest path connecting P and Q. So if I first measure the distance between P and R and then the distance between R and Q, the sum of these two distances must be bigger or equal than the distance between P and Q, which reflects the fact that the distance between P and Q is measured by the segment connecting P and Q. Therefore, a distance, as the one we defined, satisfies this inequality, which is called the triangle inequality. But why it is called the triangle inequality? Exactly because of this picture here. Indeed, the distance between P and Q is given by the length of the segment connecting P and Q, whereas the distance between P and R and the distance between R and Q are given by the length of the segments connecting P and R and Q. And we know that in any triangle, the length of one of the sides of the triangle is always smaller or equal than the sum of the length of the other sides of the triangle. And this is the reason why the triangle inequality is called in this way. In this video, going through an example, we understood what it means to define a distance. In other words, what it means to assign to every 2 points a positive number that measure the space between these 2 points. And then, from a mathematical formula for a distance on the plane, we understood what are the properties that characterize a distance. In the following video, we will answer another question, which is, what can we do using a distance on the plane? See you in the next video.